Welcome students, welcome class. In cryptography and network security courses, today we'll discuss advanced encryption standard, which is a symmetric block cipher. We have already discussed what is block cipher, and you already know what is symmetric model and what is symmetric encryption. To be precise, symmetric encryption is nothing but the model or the technique in which a single key is used for both encryption and decryption. About me, I'm Asis, and this semester I am going to take care of these CNS courses. So the process encryption and decryption form the complete process of encryption. Just the brush of the process of converting plain text to ciphertext is encryption, and the opposite, that is cipher to plain text, is decryption. Moving to the discussion part. Advanced encryption standard. Before introduction of advanced encryption standard, we have already discussed DES, that is data encryption standard. Data encryption standard is a block cipher. So AES is also a block symmetric cipher. Though there is data encryption standard, what is the need of advanced encryption standard? DES has some disadvantages, like it is quite less secure and slow as compared to AES, as because it has several numbers of round, not a fixed number like DES. DES has 16 rounds. It has different round depend upon the key. We'll see how it is. So the advanced encryption standard is a symmetric key block cipher, and it is published by NIST in December 2001. Several ups and downs here also. Several publication has been made by PIST Federal Standards. Then at last it has been accepted by a version of AES, and that makes it published in December 2001. Moving towards the actual goal, actual process of the AES. DES was a fistal cipher, whereas AES is a non-fistal cipher, and here the block size is 128 bit, and it uses 10, 12 or 14 rounds. Depend upon the key size, the rounds are respectively dependent. So the key size, which can be 128, 192 or 256, that depends upon the round number of rounds. Let's see, when there is different rounds, let's see what is happening in a single round. This is the algorithm of advanced encryption standard, or we can say the general design of AES cipher. Here we see that 128-bit plain text has been inserted into the AES algorithm, and 128-bit ciphertext getting output from the algorithm. Okay. If we see, this is 128-bit plain text. This is going inside. Then what are there in this algorithm? Pre-round transformation. Here the word is used, transformation, and here round key 128 bits, K0 to K depend upon the bit. So this should be, if the key size is 128, round should be 10. If the key size is 192, round should be 12. If the key size is 256, round should be 14. Okay. So after this, we need to see what are these individual steps. Here you can understand that like DS, in DS there are 64 bit, but it is 128 bit. So we need to input 128 bit is as a block. Okay. In AES, we need to understand some units for different states or different stages in the algorithm. Then only we can able to understand how it is working. So this is the data units. So in AES normally we use bytes. Bytes means individual byte 0 or 1. We can use it in consecutively 1 2 3 4 5 6 7 8 byte in like this, horizontally like this, or we can use it like this, either vertically or horizontally. Okay. When the 4 byte, when the 4 byte together, we can make it a word. We can make it a word, or we can represent it in horizontal or in vertical. Next is a block. Block is 16 byte, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 16 byte considered a block. This is a block. Okay. When we present this 16 byte into a matrix form, so S equal to, this is S1 S2 S3 metric form, 4 cross 4 16. This is called state, or we can say that each 4 block can be represented by, each 4 block can be represented by a word W. So word 1, word 2, word 3, word 4 we can also denote. So this is the conversion of block to state and state to block transformation. See, here we are getting B0, B1, B2, and here we are arranging like this: B0, B1, B2, B3, B4, B5. So here it is in horizontal or row wise, and we just arrange it in column wise: B4, B5, B6, B8 to B11, and B12 to B6, 15, as it is start from B0. So when we trying to convert it to again blocks, so simply we write B0, B1 left to right. This is the representation of block to state and uh, state to block transformation. Okay, clear? Why the data unit is so important in advanced encryption standard? The data unit is important because the four steps what that is involved in AES, they are using this data unit to get the uh, algorithm run. Moving to the steps. So this is the actual structure of each round in AES. So the first one is a state. So this is a state. Here 4 cross 4 matrix is there. So each and individual state or each and individual place has a byte. Like we have seen in previous slide, B1, B2, B3, B4. So this state in comes to the algorithm, then there is a sequence of substitution bytes. The bytes are substitutes. Likewise in DES, after each round, the substitution takes place for next round. Here, the state or the data that is arranged in a state, that substitute bytes, then again another state, it comes to the another state. Then in this state, the row shifts. There is a shift row. In this state, when it is go for the shift rows, so these rows are shifting, then it will come to this stage. Then the columns are mixing, then it comes to this stage. Then round key is adding here. So this is the details of a round. At the last, round key is added, then new state has been come into existence, and it comes to another state. Then the next round will be start. Okay, clear? Now we'll discuss the individual process. What is subbytes, what is shift rows, what is mixed columns, what is generation of key, and how the key has been added to the rounds. So coming to the first part, sub-bytes transformation. As we know, in AES, the states are converting from one state to another. The bytes are arranged in a states converting from one state to another. So here, let's say this byte, the row and column, the row and column number for this one table is there. From there, we find out a value, and that value has to be replaced this value, and the new value will be present here. So this state become the new state for the next steps, that is shift rows. So this is the new states for the shift rows. Let's have a one look one more time. This is the first state. We need to change the bytes of this particular location. So we need to understand the row, one's row, because it's a zero, start from zero, first row and second column. So like from this we get first row and second column, and we replace this value with the old one. That's mean old value has been replaced with the new one. So we are getting a fresh new state. After this, we go for the shift rows. See, this is the shift rows. This state, what we are getting in last steps, that is sub bytes. From the sub bytes, we are getting this state. Now, as it is a shift row, this whole row, whole 4 bytes or a word can come to the shift row algorithm. Then it shift the one byte to the left. So this can be this can be this can be this. So last one can be round to and put it on the front. If row 0, if it is row 0, no shift. If it is row 1, it is row 1, 1 byte shift. If it is row 2, if this row, the 2 byte shift. Row 3, this row 3 byte shift. After shifting of this row, we are getting another state or another 16 byte data that is ready for mixed column steps. Moving to the next, this is mixed column transformation. So this is the state we got from shift rows steps. This output we are getting from shift rows. From this shift row, this particular column, we get it here. Okay. And there are some constant is there where the column has been mixed, and finally we are getting a new column for the new state. As in the AES, there are shift byte, mix row, mix column, then add round key. These steps are there. After these states, we need to add round keys with the generator. So add round key, we need a particular column and we just add the keywords to get the new states. This is the final state for a single round. This state again, it is the input for the next round because AES have several rounds like 10, 12 and 14. So this is the final output for round 1 and it is going to be the input for round 2. Moving to the next. At last step, the advanced encryption standard add the keys or add the key in the round. So how do that key comes from, or how do that key uh, merge with the states and data or bytes? So let's have a block of cipher key as per shown in this figure, K0 to K15, total 16 byte, and as it is 16 byte, it converts into 4 words: W0, W1, W2, W3. Okay. Now The W0, the W0 XOR with a temporary byte and give to W4, then XOR with W1 and W3 and W5, W6, W7. So gradually the W0, W1, W2, the words are updating from one step to another step. If we understand this, this is the first 4 byte which represent W0. So this W0 XOR with temporary byte, then as it is the last one is W3, it generate W4, another set of 4 bytes, that is W4. This will XOR with this W1 and this will generate W5, and this process go on and this will generate W4, W6, W7. Again that W4 XOR with some temporary, then it gives rise to W8, W9, W0. Okay, so this way, this give the key and add the key to the algorithm, or add the key to the states in advanced encryption standard. You see in this particular algorithm, as it is a block cipher, we see all the states are working in a block only. If we consider this, this is a block of 4, this is a block of 4. Okay, if we consider the state, if we consider this a state, that is also a matrix of 4 cross 4. So there is a block of 4 either row wise or column wise. So at a time it works with 16-bit, and like this can have a key size or message size of 128-bit, and if it is 128-bit, the round should be 10. At last it will create so many uh, key expansion in a for AES, and finally the word with a root word and subword with the key get a randomized word and get a particular ciphertext. So this is all about AES, Advanced Encryption Standard, and this is a block cipher again, and this is a symmetric encryption technique. So we have studied symmetric encryption DES, data encryption standard, and symmetric encryption AES, advanced encryption standard, and both are AES and DES both are block ciphers, and both are symmetric encryption because the same key has been used for encryption and decryption for both the processes. I think this particular AES has been made more confusing cipher, cipher for the attackers because it has so many row shifting, column mixing for each and every round, and the rounds are depends upon the key size. Okay, so this is all about the AES. If you have any doubts, reach out to me. Go through the books once more time and go through the figures, whatever in this slide. If any doubts, you can reach out to me. Thank you. Have a good day.